welcome to my video. Before you want to watch my video, let me introduce myself. My name is Luhde Kusumasari. You can call me by Luhde. So enjoy my video and let's check this out.
So after I tell you about relation, sequence and series, now I want to tell you about introduction propositional logic. Let's begin introduction to propositional logic and English sentence translation. So, before we can really dive into the connective and syntax propositional logic, we have to talk about what a statement is. So, what a statement is? A statement is, a declarative sentence that can be either true or false. True is 1. Okay. True is 1 and false is 0. This ties very closely to Boolean logic, and in philosophy courses, you may see something like T's and F's instead of 1s and 0s. I'll be defining T and F a little bit differently later, but for now, just keep true as 1 and false as 0 in mind. So some examples of statements would be something like, the earth is round. And this can be true or false. For the most part, it is true. Second example is the cardinality of the empty set is equal to the 0, and it also true. So, there is a statement, it can be true or false. Finally, a dog has a pair of wings. There is no dog has a pair of wings. Then, this statement is false. But the point isn't whether or not these statements are true or false, but rather that they are statements, which means that is propositional logic. We cannot express things like questions, so for instance questions cannot be true or false. The other things we can't call statements would be imperatives. So, imperatives are not statements. What is it imperative? So, imperative and apparent if is a common like open the door. Those can't be true or false. So, when we talk about problems, it's no logic. We are dealing with statements which are true or false. Next is the syntax of propositional logic. Well, I've used the word propositions here. Now, propositions and statements are very closely related. A statement is usually a very specific instance, while a proposition just captures the general idea of a statement. But for this course, that really doesn't matter at all the distinction. But propositions or statements are going to be denoted with capital letters like PQR. So, for instance, P is I am sleepy and Q as I took online classes. Lowercase letters P, Q, and R are just general propositions that don't have any specific meaning, and we'll be using this for proofs. So, capital letters will have English translation, while lowercase letters will not. Now, with all of these different propositions, we can use connectives to change their meanings or combine their meanings together. So, the first thing that I want to say is that a statement or proposition on its own is a well, form, formula. Also known as a WFF or a wolf, which means that is okay in our syntax. The second statement says that not P. Or not P is a wolf. So if P is a boss, then not P is a wolf. And this not just means negation. And then, how about this? This is P and Q, or as known as carrot. So the last one is P or Q. But for now, I just want to focus on translating this into English. So here is a K of proportions and here is a well-formed formula. And I'm saying translate the well-formed formula into English. So I am just going to read this out. So R and P, arrow Q and S. And this can be translated to if R and P, then Q and S. If I take online classes and I am sleepy, then I will feel stupid and I will cry before the final test. So, this well-formed formula represents if I take online classes and I feel sleepy, then I will feel stupid and I will cry before the final test. So, I have this sentence here. If it does not rain, then it will not flood and the students can go to school. The first thing I kind of want to do is look at all the connectives. So, the first thing I see here is an if-then statement. If it does not rain, oh, I see, it's not in here. So, let me put that in red. Then, it will not flood. Yeah, I see another not there. That is another connective. And, oh, there is an and. And we can give orange of and. So, we can get that P equals to it rains, Q equals to it will flood, and R equals to the students can go to school. So, now we can write on the well-formed formula like this. Negation P, arrow negation Q, and R. So, this represents to if it does not rain, this arrow represents to then, and this represents to it will not flood, and the student can go to the school. Yeah, that's all about propositional logic. Thank you for watching. Don't forget to like, comment, and subscribe. Goodbye!